So here's a really brief update of the status for the binary operations presentation and matrices. I've been working for a while on the physical fabrication and the microcontroller coding for the large matrix. And I've been using the small matrix for, well, I used the small matrix for proof of concepting the communication while I was waiting for some of the parts of the large one and while I was troubleshooting some of the parts for the large one. Now that those two are for the most part squared away, I spent a little bit of time going back through the code base and rewriting it to accept the new way that I'm handling the information communication so that the gameplay can be multiplayer. And actually, before I explain it, let me go through and fire it. So I've got this characters.sh, which is just a shell script that sends byte arrays of information up to a WebSocket server that's actually a Raspberry Pi up on one of my workbenches, and then relays that down to all of the connected clients. The connected clients being the large matrix, the small matrix, and then this web version of the matrix. So if I fire that, we'll see all of them change relatively at the same time. The two microcontrollers are running on the same ESP32 chip, and they're running on. I wrote an animation interval for them. They're running on the same interval, so as soon as they get the information, they render out at relatively the same speed, even though there's no network time server involved as far as coordinating when each of the ticks should happen. The web version is a little bit slower. Actually, it's just not, it's out of sync. Sometimes slower, sometimes faster. I think that's a matter of it being running in JavaScript. So the way that the task list and the loop runs in JavaScript is different, and it's not you have less direct control over it than you do on a microcontroller. So that's where we're seeing the delays. For my purposes, it doesn't matter. So now each of these byte arrays gets sent up to the WebSocket server. They get sent back down to the clients, and for each of the rows, like if we look at one of these with a calculator, what we're seeing is, like, if we look at the smiley, this is the hexadecimal representation of the byte, the number that's getting printed out, or whatever, getting displayed across one of the rows. And if we look at the hex value of FF, the binary form of that is 8 bits of ones. So that's why whenever we look at the smiley, actually, let me just fire this. When we look at the smiley specifically, get the calculator, and we look at this FF, that's a byte worth of ones, which is why we see this top row as like a solid fill. And then if we look at the next row, if we look at 99, the binary form of that has 1 in the ones place, 1 in the oh god, I'm not gonna do my twos multiplication off the top of my head, but yeah, like the zero bit has 1, the first bit has a 0, the second bit has a 0, the third bit has a 1, etc. And this kind of on, off, off, on, off, off, on is what we're seeing here. We're seeing on, off, off, on, off, off, on. So that's the second row. The third row is the same 99. The fourth row is the same solid fill, etc. If we went through and wrote out each of these, so E7, and then looked at the binary form, we could see the representation of each of the rows. So when we send this entire string up, which is interpreted as a binary array on the WebSocket server and sent back down, each of the client's code says, all right, got this byte array, let me loop over each of it and then write out the bytes either to the LEDs or to the table cells here. So the next part of this is going to be allowing this to be multiplayer. The initial demo that I wrote, all of the logic was in the browser because I wanted it to be accessible by people who may not be like Node.js developers or may not be familiar with server-side code, because if it's all in the browser, you could pop open the dev tools and you could set breakpoints and work through it without any kind elaborate dev environment. So, but to support multiplayer, all of that logic needs to be up on the server so that different controllers can send up information on where to put the bricks as they shift over, or for the player controller, where the player is in a given point in time. And once that input's on the server can then go through and calculate, okay, let me render out the bricks and where they are, let me render out the player and where it is, let me advance the state a tick so that everything moves one tick, and then let me create a frame that is the merging of those two. And actually, it's probably going to send down as two separate frames so that we can handle different colors for each of them for the bricks versus the player. Let me send that down to the clients, and then now the clients are going to just be dumb renderers. They're going to say, okay, I got this frame of information for the bricks, I've got this frame of information for the player, maybe I have some metadata on whether there's a collision or not, and let me draw out that representation on each of the matrices. So, and that part's like, I mean, it's involved, but I've already written most of it. I'm just like pulling it up into a server-side code base. So, but it's very cool to be at this point where, oh yeah, I already said that. It's very cool to be at this point where the network communication is in place and I'm able to send it to multiple things at the same time. And then also to know that once I put this up in the server, like this matrix could be across the world, and it should still fire relatively in time with everything else that's seeing it. That's pretty cool.